Hello everyone, this is Dr. SUKKIRAMATHI, Assistant Professor, Department of Mathematics, Sri Ramakrishna Engineering College. So, Fourier transform, it is an important topic in engineering. Today let us discuss few problems in Fourier transform. Let us get into the video. So, this is the definition of Fourier transform. So, let f of x be a function defined in the interval minus infinity to plus infinity and be piecewise continuous in each finite partial interval and absolutely integrable in the interval minus to plus infinity. So, Fourier transform is defined only for the interval minus to plus infinity. So, infinite interval. Now, the Fourier transform of f of x, the definition of Fourier transform is defined as f of s is equal to f of x, which is 1 by square root of 2 pi f of x into e power isx dx. So, this is the definition of Fourier transform. So, this is the constant 1 by square root of 2 pi. Fourier transform is defined in the interval minus to plus infinity f of x into e power isx. F of x is the given function, e power isx. Now, the inverse Fourier transform is defined as f of x is equal to 1 by square root of 2 pi f of x into e to the power minus isx into dx. So, e to the power minus isx dx. Now, 1 and 2 are called Fourier transform pair. So, let us discuss one important problem in Fourier transform. So, in the question, the first subdivision is finding the Fourier transform. Let us write the definition of Fourier transform. Fourier transform of a function is defined as f of x is equal to 1 by square root of 2 pi integral minus to plus infinity f of x into e to the power isx dx. Now, so the first step is writing the definition of Fourier transform. So, after writing the definition, let us replace the value of f of x. F of x is given as 1 minus x square into modulus of x less than 1. So, which is equal to 1 by square root of 2 pi integral f of x is 1 minus x squared into e to the power isx. Now, so let us write the limits of f of x, modulus of x less than 1. Modulus of x less than 1 means x lying between minus 1 to plus 1. Now, let us rewrite the value of e power isx. E power isx is cos sx plus I sin sx. Cos sx plus I sin sx. So, we know that in trigonometry, e power I theta is cos theta plus I sin theta. Cos theta plus I sin theta. So, we are writing e power isx is cos sx plus I sin sx. Now, since the interval is minus 1 to plus 1, we can apply the concept of odd and even function. So, let me explain what is odd function and what is even function. First, odd function. Consider a function f of x. Consider a function as f of x. Now, replace x by minus x. If x is minus x, you get minus x. So, f of x is f of minus x, then the function is odd function. So, even. Consider f of x as x squared. Replace x by minus x, you get f of minus x as minus x the whole squared. Minus x the whole squared is x squared. So, if both x and f of minus x are the same, then this function is called even function. Now, you should know what odd and even function for cos and sin x. Now, cos function is even function because cos minus theta is cos theta. So, cos function is even function. Sin function is odd function. Sin function is odd function. Now, what about 1 minus x squared? 1 minus x squared is also an even function because, so after replacing x by minus x, you get the same function 1 minus x squared. So, this function is even. This function is also even, but this function is odd. So while multiplying even function with even function, you get even. While multiplying even function with odd function, you get odd. Now integration of any even function value from the interval minus a to plus a, f of x dx is 2 times integral 0 to a, f of x dx. If minus a to plus a, f of x dx for the odd function, the integral value becomes 0. This is for the even function, this is for the odd function. Now, we have two different results. One is even function, this is an even case, this is an odd function. So, one integral will become twice 0 to a, another will become 0. Now, the integral becomes 1 by square root of 2 pi integral 0 to 1, 2 times 0 to 1, 1 minus x squared into cos sx into dx. The another integral with the sign will become 0 because it is an odd function. Now, we need to integrate this function using Bernoulli's rule u dv. So, what is Bernoulli's rule? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. Now, algebraic function, consider the algebraic function as u, consider the trigonometric function as dv cos sx. Now, differentiate that algebraic function, u dash is minus 2x until you get 0. U double dash is minus 2, u triple dash will become 0. So, stop here. So, v, which is the integration. Integration of cos is sin sx by s, uv, u dash, v1. Integration of sin is minus cos sx by s squared. Now, v2, which is integration of cos is sin. So, you have a minus sign. So, sin sx by s cube. So, this is Bernoulli's rule. So, integration is done. Now, substitute the values here. So, 2 by square root of 2 pi. So, uv, formula says it is uv. So, u is 1 minus x squared, v is sin sx by s. So, 1 minus x squared into sin sx uv minus u dash minus 2x into v1 minus cos sx by s squared, then plus minus 2 into minus sin sx by s cube. So, integration is done. So, after the integration, let us substitute the limits 0 to 1. Now, this is, now let us cancel this term. So, in 2 you have 2 square roots. So, 1 square root get cancelled with this. So, which is square root of 2 by pi. Now, let us apply the upper limit. Your upper limit is 1. So, this is the first term. When x is 1, you get 1 minus 1, 0. So, before applying the limits, open a curl bracket and 1 bracket, square bracket for the upper limit. So, 1 minus 1 is 0, 0 into anything is 0. So, the first term will become 0. X is 1, 1 minus 1, 0, 0 into anything is 0. Now, consider the second term. We have 3 negative sign. So, put 1 negative sign here. Now, 1, it is 2. So, 2 into 1, which is 2. Your x is 1 now. You get cos s by s square. Now, minus into minus, which is plus 2 sin sx by s cube. So, upper limit is over. Now, lower limit. Your lower limit value is 0. Wherever x, replace it by 0. The first term is sin. So, sin 0, 0. We know that the value of sin 0 is 0. So, sin 0, 0. Cos 0 is 1. So sine 0, 0. So this 0, first term value is 0. Now in the second term you have x. So if x is 0, 0 into anything is 0. So 0. Third term, in third term as well we have sine. So cos sine 0, 0. So plus 0. So this is your lower limit value. This is your upper limit value. Let us simplify this. So this is square root of 2 by pi. So taking 2 outside, so 2 into sine sx, taking s cube as LCM, so s cube into, so sine sx, so write this as the first term, sine sx minus, we have only s squared here, so taking s as LCM, so you have a minus sign, so this is s cos s. So this is your Fourier transform of a function. So we got the value of Fourier transform. Next subdivision is subdivision 1. To find the value of integral 0 to infinity sin t minus t cos t divided by t cube. To find the value of integral 0 to infinity sin t minus t cos t divided by t cube. So to find the value of this, we need the formula of inverse Fourier transform. So let us, so by inverse Fourier transform, f of x is equal to 1 by square root of 2 pi integral minus 2 plus infinity f of s into e to the power minus isx into ds. F of s e to the power minus isx ds. F of s is nothing but the Fourier transform. So just now we got the value for Fourier transform. Now we can replace the value of Fourier transform. F of x is the given function. Now, so this is equal to 1 by square root of 2 pi integral minus 2 plus infinity. Now let us replace the value of Fourier transform. The value of Fourier transform is 2 into square root of 2 by pi sin s minus s cos s divided by s cube. So this is by the previous subdivision. So 2 into square root of 2 by pi sin s minus s cos s by s cube. Now e power minus isx. Replace e power minus isx by cos sx minus I sin sx into ds. Now we know that this is an even function. This is an odd function. Now you need to verify whether this is an odd or even function. So for that replace s by minus s. If I replace s by minus s and everywhere if I replace s by minus s, I get this as an even function. So even into even is even into odd will become odd, hence even into odd becomes 0, integral value will become 0. So we have only the first term exists. So integral square root of 2 by pi 2 times integral 0 to infinity. So 2 into square root of 2 by pi sin s minus s cos s by s cube into ds. Other integral value is 0 because of the odd function. Now let us multiply this s into 2 into 2 is 4, 1 square root get cancelled, square root of pi into square root of pi is pi, So 4 by pi integral 0 to infinity sinus minus s cos s by s cube into ds. Now let us come to the left hand side. In the left hand side it is f of x. The left hand side it is f of x. Let us replace the value of f of x. F of x is 1 minus x squared. Sorry, this has to be included. So into cos sx, cos sx. Now, so this is the result after applying the inverse Fourier transform, but you need to prove sin t minus t cos t by t cube. So in this result we do not have any cos function, but here we have a cos function. Now we know that cos 0 is 1. We know that the value of cos 0 is 1. So we are going to replace x as 0 in this function. Replace x by 0. So left hand side is 1 minus x squared, so which is 1 minus 0, 1 minus 0. The right hand side we had 4 by pi integral 0 to infinity sinus minus s cos s divided by s cube into, now we have replaced x as 0, so cos 0 value is 1, so 1 into ds. Now cross multiplying the term, so cross multiply this 4 by pi to left side, you get pi by 4. So pi by 4 is equal to integral 0 to infinity sinus minus s cos s divided by s cube into ds. Now in the answer it is given as sin t minus t cos t. So just we are going to replace s by a dummy variable t. Replacing s by t, you get the answer as integral 0 to infinity sinus minus s cos s divided by, sin t minus t cos t divided by t cube into dt, which is pi by 4. So we got the answer for subdivision 1, which is pi by 4. Now, so in subdivision 2, to find the value of integral 0 to infinity sin x minus x cos x divided by x cube into cos x by 2 into dx. So to find the value of this, let us consider the previous result, which is f of x equal to 4 by pi integral 0 to infinity sinus minus s cos s divided by s cube into cos sx ds. So consider this result from the previous subdivision. Now compare both the results. Here in the place of sx it is x by 2. So we are going to replace x by 1 by 2. So substitute x by 1 by 2. If x is 1 by 2, we get f of 1 by 2 is equal to 4 by pi integral 0 to infinity sinus minus s cos s divided by s cube into cos s by 2 into ds. Now let us find the value of f of 1 by 2. F of x is given as 1 minus x squared. So f of 1 by 2, which is 1 minus 1 by 2 the whole squared. 1 minus 1 by 2 the whole squared is 4 minus 1, 3 by 4. So your left side value is 3 by 4. I am cross multiplying this with the left side, which is pi by 4, which is integral 0 to infinity sin s minus s cos s by. So there is no change with the right side. So cos s by 2 into ds. So if you multiply this, you get 3 pi by 16. Almost we got the result, but we need to find the value of sin x, x cos x. So everything is in terms of x. We got the result in terms of s. So we are going to replace s by a dummy variable. So replacing x by a dummy variable s, we get the result. So this is integral 0 to infinity sin x minus x cos x by s cube into cos x by 2 into dx. So wherever s, replace it by x. So that's all. So this is a very important problem in Fourier transform. So there are 3 subdivisions in the problem. First subdivision is finding the Fourier transform. In the second subdivision, we use the results of inverse Fourier transform. Third subdivision is the continuation of the second subdivision. Still we have few more topics to be covered in Fourier transform. Let us continue in the next class. Thank you.